Welcome back, friends. Let's start with some of the basic concepts of kinematics. So first of all, I'm going to start with the displacement. So let's suppose there is a person standing here and he covers 100 meters in the east direction. So this is east direction. He ends up covering 100 meters in east direction. And then he stops here, and then he started moving in the backward direction, in the opposite direction, and he covers 50 meters in the opposite direction. And I wanted to find his displacement, net displacement. So the idea of the net displacement is it is the distance from the origin point. So from where we started, this person started from this point, and it is the distance, the final distance from the original point in a specific direction. That's what displacement is. So starting from here, his final position is somewhere here. Now what is his net displacement with respect to this position, this location? So he moved 100 meters in the forward direction, so d1 is equal to 100 meters, which is in the east direction, and then he moved in the opposite direction, so d2 will be equal to 50 meters in opposite direction, which is the west direction. And I wanted to find d net. Just by looking at the diagram, you can say that he is at a distance of 50 meters. Let me change the color. So he will be at a distance of 50 meters from the original point. So this is 50 meters, and 50 meters in which direction? In the east direction. And we wanted to solve it mathematically now. So the formula is d net equal to sum of the rest of the displacement. So how many displacements are there? There are only two displacement vectors in this one. So d1 plus d2. Now d1 is 100 meters, so this is 100 meter east. Anything moving towards the east we generally consider it as positive, and east is positive, and west we consider it as negative. And same thing goes with the north, we consider it as positive, and south we consider it as negative. So this is 100 meters east, and then plus 50 meters west. Because this is in the west direction, so I will change the sign. So this will become negative 50, and then this is 100, this is 100 positive, so this value will remain as positive. So 100 minus 50 is 50, because the final result is positive, so this will come out to be 50 meters east direction. So that's the net displacement for the person. So remember this thing, the most important thing is net displacement is always with respect to the starting point. Now we're going to talk about the next concept, that is the concept of velocity. So velocity, velocity. So velocity is the formula for, first of all, the formula for the velocity is the d final minus d initial divided by time. So if I have to define the velocity, it is the rate of change of displacement with respect to time. So again, I'm going to take an example. If this person is standing here and he starts from this location and he covers 100 meters in east direction, and then he takes 20 seconds to complete this journey. I wanted to find his velocity. So initial point we'll consider as 0, and the final point is at a distance of 100 meters. So d final, what is the final location? So 100 minus 0 divided by time it took was 20 seconds. So I won't put the seconds here. So velocity is equal to 100 divided by 20, which comes out to be 5. And what are the units of velocity? If I wanted to find out, we can derive the units of velocity also. This is the displacement is in meters and time is in seconds. So the units of velocity becomes meter per second. So 5 meters per second, and this value comes out to be positive, so it means it is towards the east direction. Now I'm going to change it a little bit. Now let's say he is at a this is the origin point, and then he is at a distance of 100 meters from the origin point, and then he moves 200 meter in the east direction, and this journey he covers in 10 seconds, or 10 seconds. I wanted to find his velocity. I wanted to find the velocity of the person for this region, starting from 100 meter displacement up to the 200 meter mark. So what will be the velocity for this region? It will be 200 final displacement. This is final, this is initial. 200 minus 100 divided by time taken to cover this journey was 10 seconds. So this will be 200 minus 100 is 100 divided by 10, which comes out to be 10 meters per second. Now I'm going to talk about another basics, that is acceleration. So acceleration is represented with symbol A, and it's also a vector quantity. Similarly, I forgot to tell you about the velocity. Velocity is also a vector quantity because we were talking about the direction, and that anything with which we talk about the direction and the magnitude, it's a vector quantity. For example, if I go back in this is the magnitude. This portion is this is the magnitude, and because this is positive and this is in east direction, so this is the direction part, this is the magnitude part, so this is a vector quantity. Now let's talk about the acceleration. Acceleration formula is velocity final minus velocity initial divided by time. If I look into this formula, it is if I wanted to define this acceleration, it is the rate of change of velocity with respect to time. So let's look into it, how we can write a real life situation for this one. So let's say there is a car which is moving in the east direction at 20 meters per second. Now after a certain time, after 10 seconds, it starts throttling, and after 10 seconds its velocity reaches to a measurement of 50 meters per second. I wanted to find acceleration of this car. So acceleration is final velocity, which is 50 minus 20 divided by 10, and make sure we need to take the directions into consideration. This is in east direction, this is also in east direction, so both are positive values. So 50 is positive, 20 is also positive. This negative sign, let me change the color, this negative sign belongs to the formula. This negative sign is not associated with 20. This negative sign is associated with this formula here. 20 is positive still because this is in the east direction. So 50 minus 20 is 30, and then divided by 10. So the acceleration is equal to 3. Now I wanted to find the units. What are the units? Units of velocity is meters per second, and units of acceleration, units of time is second. So the units will be meters per second square. So hopefully you were able to understand some of the basics of the kinematics. By keeping these basics in mind, in the next video lecture we will talk about some more concepts, some real life concepts. So I'll see you in my next video. Bye now.